Welcome to Solving with Elimination Part 2. So during Part 1, when we were solving with elimination, the variables were opposites of each other, or at the very least they were the same number, and we could multiply by a -1 to make them opposites, and we could solve quickly. So we still want to use the elimination method to solve because the x's and the y's, they're stacked up, we're in standard form. But again, to use elimination, we want to add these equations together to get a variable to cancel out. And right now they are not ready to cancel out. So you want to ask yourself, how could I easily get these equations ready to cancel? What I notice is that my y's, they are factors of each other, like 4 and 8, and one's positive, one's negative. So I could easily multiply this top equation times 2 to obtain to make these y's be opposite coefficients. So let's see what happens here. If I take 1 times 2, and again this is like distributing, I need to take 2 times all three terms. So 2 times x gives me 2x, 2 times -4 gives me -8y, and 2 times 3 is 6. So now these are stacked up nicely, they're in columns, and I have opposite variables ready to cancel out. So that's all there is on this step, is on this video is we're going to just keep practicing multiplying to get the problems ready to eliminate. So now 2 plus 2 is 4. My 8y's cancel out. I bring down my equal sign, and -2 plus 6 is 4. And so to get x by itself, I would divide both sides by 4. And x would equal 1. And so again, once you have your first value, we're going to plug it back in to either equation, whichever one looks the easiest. I'm going to pick this top equation here that says x minus 4y equals 3. And I'm going to take this 1 that we just found the answer for, and I'm going to plug it in for x. Now the nice thing here is there's nothing to multiply times, so I don't need to really use parentheses when I plug it in. I'm just going to go ahead and write 1 minus 4y equals 3. So to get y by itself, I'm going to subtract 1 from both sides. And 3 minus 1 is 2. And then divide 2 by -4. I'm going to get -1/2. Let's see if that works. Let's try in the bottom equation here. So if I took 2 times 1, so again, my ordered pair right now is 1, -1/2. It's okay to get fractions and decimals sometimes with this, but let's work this out and make sure we didn't make any mistakes. So again, I'm going to take 1, plug it in for x, and 1/2 in for y. So 2 times 1 plus 8 times -1/2 equals -2. So 2 times 1 is 2. 8 times -1/2. Half of 8 is 4, and I need to make it negative. So this would be 2 minus 4 equals -2. And that is true. So this is our answer for this first example. Let me specify here, if you're doing the paper copy of the notes, this is like example 5, but this corresponds with example 1 on the Google Slides for our continuous learning unit. And let's go through that again. Again, this is example 2 continuous learning unit. It's example 6 if you have the paper copy of the notes. So we're trying to use elimination here. We need to cancel either the x's or the y's, and I'm trying to find a easy constant to multiply by. Now you can multiply both equations if needed, but I want to do the least amount of work. So if I see that 5 and 3, they're not factors of each other, but 10 and 2 are. So I could turn this 2 into a 10 by multiplying by 5. But I don't want to just multiply by 5. I need this to be a negative. So I'm going to multiply by a negative 5 so that this term then turns into negative 10. So when I do that, negative 5 times 2, I'm going to get negative 10x. Negative 5 times 5 is negative 25y. And then negative 22 times negative 5. As we're going through all these examples, it'd be really good that you're working them out on notebook paper and have a calculator with you for problems that pop up like this. So negative 22 times negative 5 is positive 110. So again, this example or this equation is now gone and we're ready to add. So 10 and negative 10 cancel like we wanted, they eliminated. And 3 and negative 25 is negative 22y. And now we have 22 plus 110 is 132. And to get y by itself, we would divide by negative 22. And the value of y then is negative 6. Once you have your first value, you can plug it back in. I'm going to pick this bottom equation since I can read it. It says 10x plus 3y equals positive 22. And this answer we just found of negative 6, I need to plug it in for the y here. So I would have 10x plus 3 times negative 6 equals 22. Simplifying here, 10x, 3 times negative 6 is negative 18. I would add 18 to both sides, so 10x is going to equal 40, I believe. Divide both sides by 10, and x is going to equal 4. So my ordered pair I'm looking at here is 4, negative 6. Let's double check and see that that works. So let's plug it into this top equation. 4 times 2 is 20 plus 5 times negative 6. So that would be, or 4 times 8, excuse me, 4 times 8 is, 4 times, let me say that again. 2 times 4 is 8. And this would be a negative 30 because it's 5 times negative 6. So negative 30 plus 8 is indeed negative 22. So that ordered pair is correct. Now I am talking you through this, but you can just type that straight into your calculator. 2 times 4 plus 5 times negative 6 and hit enter. And if it doesn't spit out that negative 22, you know that you need to check your work here and find a mistake. Okay? So let's look at example number 3. So here on example number 3, we have the x's with 2 and 5 and the y's of coefficients of 3 and 2. Now 2 does not go into 5 an even number of times, 2 does not go into 3 an even number of times, so these are not, neither of them are factors of each other. And so you just need to decide, do you want your x's to cancel or do you want your y's to cancel? So how could we decide? Well, if I turn these x's into a 10 and a negative 10, I'd be multiplying by 2 and or 5 and negative 2. Or I could turn these into 6's, which is a little bit smaller. So you might choose to cancel your y's. So let's go ahead and try that. Let's take this top equation times 2. And if I take the bottom equation times negative 3, then these y's would become 6 and negative 6. So let's see what that would look like. 2 times 2 is 4x. 2 times 3y is 6y. And 2 times 2 is 4. In the bottom equation here, if I distribute this negative 3 all the way through, I would get negative 15x and negative 6y, and 16 times negative 3 is negative 48. And now I have opposite coefficients. I'm ready to add the equations together to eliminate. So 4 and negative 15 is negative 11x. My y's eliminate like I wanted. Bring down my equal sign, and 4 and negative 48 is negative 44. Divide both sides by negative 11. X is a positive 4. Plugging back in, I'm going to choose the top equation just because it's a little bit simpler numbers to work with here. So I'm going to have 2x plus 3y equals 2, and I'm going to plug this this 4 in for x. So 2 times 4 plus 3y equals 2. 2 times 4 is 8. Simplifying. I'm going to subtract 8 from both sides. I'd be left with 3y equals negative 6. Divide both sides by 3. And my answer there would be negative 2. So my ordered pair that I think is correct is 4, negative 2. Let's plug it in and make sure. So I use the top equation to get my second answer. Let's plug in here. So 5 times 4 is 20 minus 2 times negative 2. So that'd be 20 minus 4, and that is 16. So that would be my correct answer. I do have one more example if you'd like to have one to try on your own. It would be explained in the Google Slides. But that concludes my video and explanations for Elimination Part 2.